consider our success, what we count as our success. So, what can I identify? 54. Which variable is that? Not quite. That's my success. So that's my x. P hat is the probability of a success. So it's going to be a decimal. So it's going to be, you know how like in binomial you had P, which was the probability of the event of this success? P hat is the probability of success of your sample. It's going to be out of the 150. So my n is the 150, and I'm going to use these two pieces of information to figure out what p hat is. So p hat is going to be from the formula above, my x over my n. So what are we going to get? Over 150, yeah. What? 36. All right. So my probability for the success is 0.36, or you can think of it as 36%. What's the probability that they do not have a central air conditioning, also known as your probability of a failure? We're going to call that Q hat. How do I find Q hat? 1 minus your P hat. So 0.64. So P hat and Q hat, just like in the binomial, should always be between 0 and 1. There's some decimal that's in between 0 and 1. If it's a percent, 0 and 100%. Questions on that? All right. That's obviously not my main goal. I want us to be able to use p hat to come up with intervals or run our tests. If it only asks you for the point estimate or to find p hat and q hat. Now we actually want to find an interval. So suppose 500 nursing applicants include 60 from men. Find the 90% confidence interval for the true proportion of men who applied for the nursing program. So what can I identify? N is 500. Okay. X is 60. And my confidence level is 0.9. All right, so I'm going to need my p hat, which is going to be what? 60 divided by 500. 0.12. All right. Then I need q hat, which is 1 minus the 0.12, which gives me 0.88. All right, now I want to eventually start building the pieces for the interval. So we're going to need the standard deviation for this sample, which is the square root of p hat times q hat, so 0.12 times 0.88, and you divide it by n. So we'll divide it by 500. That's a part of what we need. So let's see what that gives us. Z critical values. So I need a Z alpha divided by 2. What is alpha? Well, it's 1 minus the confidence level, so it's going to be 0.1. So alpha divided by 2, 0.05. And we can find it by backwards looking at 0.05 or doing inverse norm of 0.05. Oops, I'm kind of running my step. With a 0 and a 1 to get the z-score. Now remember, this is going to give you the negative version, but the positive critical value is the same number, just the positive version of it. So what value is that going to give me? Close. I think this one is 1.64. Negative 1.64. And we can, like I said, you add and subtract the margin of error, so you can use the positive or negative version, and it's not going to make a difference. All right, then let's put our pieces together to actually get the margin of error. So 1.64 times our standard deviation of 0.0145, and let's see what our margin of error comes out to be. Zero, 2, 3, 7. All right. Then, just like we built our other intervals, we want to use our point estimate and our margin of error. So this confidence interval is going to be p hat, which is 0.12 minus 0.0237, and our p hat, so 0.12 plus your margin of error of 0.0237. And this will give me my confidence interval for this applications for nurses. Nine, 6, 3. All right. Point 1437. All right. Now, since we're back to having proportions, and proportions went along with the binomial, which was always percents, when I talk about this in a sentence, I want to use percents. So we're still going to start at the same and say we are 90% confident. We're going to say, we're not talking about means, so we're talking about the proportion, and they asked me about the true proportion, meaning the true proportion of the population. So we're going to say we're 90% confident the true proportion of men who applied to the nursing program is between, and this is where I want to put it in percents. So it's between 9.63% and 14.37%. Questions? The formula for S, that came from just this portion of the margin of error. So that portion is my standard deviation. And then you multiply your standard deviation by the critical value. So that's where S came from. Other questions? Are 1,721 people, and found that 15.9% of the individuals purchased religious books at a Christian bookstore. Find the 95% confidence interval for the true proportion of people who purchased their religious books at a Christian bookstore. All right, what can I identify in there? N. 1,721. What else can I identify? P hat. Good. They gave you a percent, so they already gave you P hat. I'm going to turn it to a decimal, so 0.159. What else do I have? Confidence level of 0.95. Now the issue is that if we were doing this by hand, it wouldn't be an issue because we want P hat and we're excited. The other side that is an issue is that your calculator actually wants to know what X is. So if we're given P hat, can we find X? Times it by the N. Because if P hat is equal to X over N, then multiply both sides by N, and you're going to be left with X equals N times P hat. So if you are given p hat, you're still not stuck. You can use technology. We just need to say 1,721 times the 0.159. And this will tell me how many X's or successes they actually had. So let's see what that gives us. 273.64. All right, the other catch is that your calculator does not want a decimal. You have to have a whole number amount of events that happened. So we want to round, and you can follow normal rounding rules and say that it's a 0.6, so we'll go to 274. Just because your calculator will not take that decimal. Then I've got n, x, and the confidence level, which is all my calculator is going to want. So let's go over to our testing area. We're building intervals, so we have to go down to the interval section. We are doing a 1 prop z int. So we're dealing with proportions. So it's got its own set that we have to go to. Did everyone find it? 1 prop z int. Meaning we have one proportion, and we're going to build a z interval from that one proportion. It's A, yeah. Once you get inside, it's going to ask you what's x, what's n, and what's your confidence level. We said x was 274. Our n was 1,721. And we want to be 95% confident, so 0.95 for the C level. Everybody get to here? Did it work? All right, let's calculate. And it tells me that I am between 0.14192 and what was the upper?
0.1765.
All right, so that's my interval. When I talk about it, I want to turn it into percent. And what would we say about this interval?
We are 95% confident.
Confident of what? So the true proportion of people who buy their religious books at a Christian bookstore is between 14.19% and 17.65%. Questions on that? Confidence level is 0.95. What else? P hat, what is it? 0.4. And within 2% is my ME, my margin of error. So 0.02 for the margin of error. Now, no matter what I have to find the critical value. And since we know what p hat is, that means we're using that first formula. So let's figure out what our z alpha is. So what is alpha to begin with? 0.05. And we need alpha divided by 2. So 0.05 divided by 2, 0.025. So we can look that up. We can remember from before what that gave us, or use inverse normal. And what is it going to give us? 1.96. And it's probably going to give you the negative version. You can use the positive or negative version because you're going to square it in the end, and it's not going to make a difference.